Today I am going to talk about the third type of problem, which comes from the signal flow graph. And the question will be like, draw the signal flow graph and find transfer function using, there will be equations will be given there, like x1 is equal to minus g5 x4, x2 is equal to g1 x1 plus g3 x3. This x1, x2, x3, x4 and this g, I mean g1, g3, g2, g3. Seeing this, you have to understand what will be the signal flow graph. And here the x1, x4, x2, x3, this will be the nodes, and the corresponding gains will be g1, g5, g3, g2. Now we have to understand how the paths will be connected. That is the most important part here. So first let me draw the nodes. So there will be actually 4 nodes. Let me draw it here. This is x1, node 2, that will be x2, this will be x3 and x4. This will be 4 nodes. Now if we see the first equation, that is x1 is equal to minus g5 x4, means x1 and x4 will be connected and the gain of that path will be minus g5. Now as g1 is dependent on x4, x4 will be converging, or that will be going to x1. So the path will be, or the feedback path will be drawn like this, and here the gain will be minus g5. Finally the output will be from x4, obviously, that is cs, and the input as we taken before, that is rs. Now the second equation, x2 is equal to g1 x1, x2 is equal to g1 x1, means from x1 it will be coming and the gain will be g1 x1 and g3 x3, means from here it will be coming and it will be, the gain will be g3. Now the third equation, x3 is equal to g3 x2, means from x2 one path will be there and that gain will be g2. Now the last equation, x4 is equal to x3 plus g4 x1. Hence as there is nothing, means 1 is there, 1 into means the gain will be 1. So x3 to x4 there will be a path and the gain will be 1, and from x1 to x4 there will be a path whose gain will be g4. So now our signal flow graph is completed, and now we can find the transfer function using Mason's gain formula. So here we can see that there is 1 and 2 forward path. This can't be a forward path as it is a feedback path, means there is 2 forward path, means number of forward paths is equal to 2, and the corresponding gains will be p1 is equal to g1 g2 into 1 is equal to g1 g2, p2 will be only g4, and now you have to find how many loops are there. So this small one I am taking first, this can be a loop, this can be a loop, and no, this can't be a loop, but this path I am drawing it with highlighter. This path can be a loop. This one, this one the second one, and this one the third one. So there can be 3 loops. You can see that. So the first loop gain L1 will be G2 G3. Here I am taking the smallest one, and that is G2 G3, taking the smallest one, and then L2 will be L2 I am taking as this one I am taking the second one, that is G1 G2 and minus G5, so minus can be here, it will be minus G1 G2 G5, and the last one L3 will be minus G4 and G5. So all the loop gains are found, forward path gains are found. So now we have to see any non-touching loops are there or not. So the number of 2 non-touching loops here will be 1. So number of, I am writing it like this, 2 non-touching loops combination is 1, and that will be actually this bigger one and this smaller one. They are not touching each other, but this one are touching, this smaller one and this one are touching. So there will be one combination, and the gain of that combination will be G2 G3 into G4 G5 into minus G4 G5. So finally minus G2 G3 G4 G5. So now you can calculate the value of delta. So the delta value will be 1 minus L1 plus L2 plus L3 plus this value which we have calculated right now, G4 G5, as per the Mason's gain formula. You know that. So L1 L2 L3 value we can put here from these values, and we can find out the value of delta. But as there is 2 forward path, we now have to calculate the value of delta 1 and delta 2. So the value of delta 1, if we take the L1, means G2 G3, if we take P1, that is G1 G2, it is touching all the loops. So the delta value will be 1, my delta 1 value will be 1 minus 0 is equal to 1. But delta 2 value will be 1 minus G2 G3, as this forward path is not touching this loop. Hence 1 minus the gain of that non-touching loop. So the value will be 1 minus G2 G3. So everything is found. Now we can apply the Mason's gain formula and find out the transfer function is equal to Pk delta k by delta is equal to, here k value will be 1 and 2, so p1 delta 1 plus p2 delta 2 by delta. Now we just have to substitute the value of p1, that is g1 g2, delta 1 is 1 plus p2 delta 2, p2 is only g4 and delta 2 value is 1 minus g2 g3 divided by 1 minus L1 plus L2 plus L3. If we calculate the value, you will get minus G2 G3 plus G2 G1 G5 plus G4 G5 and this value, that will be minus G2 G3 G4 G5. so this will be the final answer. So in this way, if equations are given, now you know how to do the problems and how to find out the transfer function. This is the type 3 problems. Type 4 problem I will upload in my next video, and that will be the last type of problem comes from the signal flow graph. So thank you. If you understood the whole video, please like and subscribe and share with your friends. It will be very helpful to them, and I'll be giving the next video link in my description. You can check that after my uploading. So thank you, and don't forget to press the bell icon, because whenever I upload the video, you'll get the notification. So thank you.